and LSA 7. And all LSA will carry two information. One is router ID, and second one is link ID. Link ID. These two information. So inside the router LSA, as you said, all router in OSPF domain generate LSA 1. Okay, so let's say router ID of router 1 is nothing but 1.1.1.1. Router ID of router 2 is, let's say, 2.2.2.2. And router ID of router 3 is, let's say, 3.3.3.3. Okay, these are the router ID of these three routers. Okay, so in router LSA 1, as I told you that each router means router 1, 2, 3, all routers will generate their LSA 1. Inside their LSA 1, there will be these two information. First of all, router ID and link ID. Router ID will be the router ID of advertiser router, who is advertising who is generating that LSA, you can say, or who is advertising that LSA. So let's say router 1 is generating LSA 1. So router ID will be 1.1.1.1, and link ID will be also router ID of the router who is generating the LSA 1.1.1.1. That means in router LSA, router ID will be the router ID of advertiser router, and link ID will be also the router ID of advertiser router. Done. So first LSA, router LSA is generated by every router in OSPF domain generates router LSA, and in router LSA, router ID will be the router ID of router who is generating that LSA, and link ID will be also the router ID of that router only. Okay, after that, let's say router 1, this is LSA 1 of router 1, router LSA of router 1. Then there will be information about link. So how many links are there? How many links are connected with router 2? 2 number of link. Yes or no? There are 2 links directly connected with router number 1, F0/0 and F1/0. So there will be information about link, like as you know, the network which is running on link and cost. Okay. So inside this router LSA, definitely there are 2 links, but router 1 will consider there are 3 links. As I told you yesterday also, that on fast Ethernet link means on Ethernet media, by default network type is point to point and broadcast, and on broadcast network type router consider their neighbor also as a link. So total number of link over here is, total links will be 3. One is 10.1.1.0/24, and what will be the cost over here? So that will be the information. Then 12.1.1.0/24, after that cost for this network, and 2.2.2.2 and cost to reach this neighbor. Okay, so router will consider 3 links. Okay, so in this topology I'm just going to configure OSPF on all interface, and in the database of router 1, guys, there will be how many number of LSA 1? Like if I will talk here, I have configured, let's say, OSPF on all routers. OSPF is running on all interfaces of all routers. So if you will check the database of router 1, in the database of router 1, how many number of LSA 1 will be there? There will be one LSA 1 of router 1, there will be one LSA 1 of router 2, and there will be one LSA of router 3. So total number of LSA 1 that will be carried in database by router 1 is 3. Yes or no?
Yes, sir. But sir, it is only possible if all 3 are in the same area.
Yes, if all are in same area, definitely. You know, router LSA, every router generate LSA 1, but always keep in mind LSA 1 never cross area.
Cross area, yes.
It cannot cross area. Okay, so we will understand, right, when we will discuss about the area. Don't worry. For now, all router will have 3 number of LSA1. Router 1 will have LSA1 of router 1, router 2 and router 3. In the same way, router 2 will have LSA1 of all routers and router 3 will have also LSA1 of all routers. Means database of all routers are identical, guys. Yes or no? See, there is no any change in database of router 1, router 2 and router 3. Database of all routers are same. Okay, so let me do one thing. Let me configure OSPF over here. For that, let me take access of this router, and here I am going to check IP. Enable so IP protocol. No, I am not running any protocol. So IP interface brief, exclude and assign. So here we have some loopback. Let me remove this loopback. No interface, loopback 1, loopback 2 and loopback 3. And interface f1/0 no set, and IP address is 10.1.1.1.255.255.255.0. Okay, so IP interface brief escort. Now you can see the IP configuration. Okay, let me check IP configuration on router 2. Here enable so IP interface brief exclude and assign 12 on 0/0 12.2 on 1/0 23.2. Okay, just let me configure the LAN interface. Only LAN interface configuration is left here. So interface f2/0 no shutdown, and IP address 20.1.1.1 255.255.255.0. Exit. And now let me check IP on router number 3. Enable so IP interface brief exclude and assign. Here we have some loopback. So say no interface loopback 1, no interface loopback 2 and no interface loopback 3. Interface f1/0 no shut, and IP address 30.1.1.1 255.255.255.0. I have configured IP address on all router. Now I am going to enable OSPF. So let me enable OSPF on router 1 first. Router OSPF process ID 1 and router ID. I'm configuring router ID 1.1.1 manually over here. Done. After that, interface range f0/0 and f1/0. I'm going to run command IPOSPF 1 area 0. This is how I can enable OSPF on both interface, right? After that, we need to configure one interface as, okay, wait for that. Config e router OSPF process 1 and router ID 2.2.2.2. Exit. Interface range f0/0 and f1/0 and f2/0. IPOSPF 1 area 0. I have configured OSPF on all interface in area 0, and let me configure OSPF on router 3 also. Router OSPF 1 and router ID 3.3.3.3. Exit. Interface range f0/0 and f1/0. IPOSPF 1 area 0. Done. Is it clear to everyone? Now wait for some time. Router 2 and router 3 will take some time for the neighborship. After that, they are going to exchange the database. Router 1. Okay, neighborship is full. Router 2 and router 3. So IP OSPF database. database. In database, you are able to see some network LSA as well, right? So guys, link between router should be configured as point to point. Yes or no? That this link should be point to point because I have connected only two devices. Means router 1 is connected with only router 2 here. We don't have multiple devices on F0/0. So this is point to point. So if you will configure this link as point to point, then there will be no network LSA. OSPF network type, I am talking about OSPF network type, that you will understand in details when we will start OSPF network type. For now, you can check one thing. So IP OSPF interface fast Ethernet 0/0. On this interface, OSPF network type is broadcast. But between routers, between point to point devices, my network type should be point to point. So here I can change the network type by running command interface F0/0 IP OSPF network, and we can say point to point. Okay. So once I will change network type, neighborship bill goes down. So let me configure network type, same network type on router number 2 also. Config T, because for the neighborship, as you know, network type should be match. Yes or no? Interface F0/0 IP OSPF network point to point. Point to point. And interface F1/0 also IP OSPF network point to point. Sorry. And on R3 F0/0 also, let me configure network type point to point. Otherwise neighborship bill goes down here. Interface F0/0 IP OSPF network point to point. Done. Now on router number 1, if I will show you the database, so IP OSPF database. In database, you can see these are LSA1 and this is LSA3. Who is generating this LSA3?
Router 3.
Router 3 is generating this. Sorry, LSA2 network LSA. Wait, there I have configured point to point network type. So now you can see router 3 is not advertising any network LSA. Now in the database of router 1, we are able to see only router LSA. This is database of router 1. If I will show you the database of router 2, so IP OSPF database. See, is there any change, guys, in between database of router 1 and router 2? No, everything is same, right? These are LSA 1. Router 2 have 3 number of LSA and router 1 have also 3 number of LSA. See, this is LSA 1 of router 1, means 1.1.1.1. How many links are there? 3. This is LSA 1 of 2.2.2. How many links are there? 5. But in real, you can see how many links are there. 1, 2, 3 only.
Yes.
Means if you will open it in detail, let me open. So IP OSPF database, after that router and 1.1.1.1. I want to open LSA 1 of router 1 in detail. So here also we are able to see one link is 12.1.1.0. Okay, fine. Second link is 10.1.1.0. Okay, this is also correct. And one link is 2.2.2.2. So this is what, guys, neighbor. Yes or no? So it is considering their neighbor also as link. It is considering their neighbor as a link. But on serial link, if I will connect serial link between these routers, so it will not consider their neighbor as a link. So that's why on router number 2 we are able to see total number of link is 5, and on router 3 we are able to see total number of link is 3. Because one is this one F1/0, one is 0/0, and one is neighbor. Router 2 have 3 link and 2 neighbor. So total number of link is 5. Getting my point? In GNS3, if I will connect serial link between two routers, then it will not consider their neighbor as link. So this is behavior of OSPF on Ethernet link only. So this is router LSA, LSA1. LSA1 problem with LSA1 is LSA1 cannot cross area. Router 1, router 2, and let me use one switch over here, let's say. And between router 1 and router 2, I am going to use serial link. So guys, in this scenario, router 1 have how many link? Router 1 have two link, two number of link, right? So I have connected serial link between router 1 and router 2. So router 1 is not going to consider their neighbor as a link. So in the database of router 1, there will be only two number of link. Router OSPF1 and router ID 1.1.1.1 exit interface range F0/0 and serial 2/0. Okay, here I cannot use range command as well. IP OSPF1 area 0 and interface S2/0 IP OSPF1 area 0. So IP interface brief. Okay, now let me configure R2. IP OSPF1 area 0. Soon OSPF neighborship will come up between router 1 and router 2. And see, neighborship is up, and so IP OSPF database. So this is database of router 1. How many links are there? No, this is the output of R3 in EVNG. Where is this R1? So IP OSPF database and router 1.1.1.1 12.1.1.0 10.1.1.0. So there are only two network information. One is 2.2.2.2 directly connected with router. No, here it should not store, consider their neighbor as link. So number of link is here also we are able to see 3. I think on router number 1 okay, first of all, see, by default network type on serial link is point to point, and by default network type on Ethernet link was broadcast. That means OSPF network type is also depends on link type. OSPF by default OSPF network type depends on link type. By default network types on serial link is point to point, And by default, network type on Ethernet link is broadcast. On serial link, it should not consider their neighbor as link, I think. But so IP OSPF network, so IP OSPF interface serial 2/0 network is point to point. We don't have any problem. And so IP OSPF database. Here we have 3 number of link. Here also we have 2 number of link. One is neighbor and one is serial 2/0. Okay, we will see it later. Don't worry. On serial link, I think router is not considering their neighbor as a link. But on this is behavior of Ethernet, OSPF on Ethernet link. Okay, we will see it later. Done. So now guys, if I will show you the database of router 1, see how a single router 1 can design entire topology by checking their on database. First of all, see, this is the topology. Right, let's say I don't know the topology. So I am router number 1. I will check what first. So IP OSPF database. So by running this command, router will came to know that how many routers are there in this OSPF domain? 3 routers are there. There are 3 routers in this OSPF domain. And this is my router ID 1.1.1. Okay, first of all, it will check there on LSA1. It will open there on LSA1. So IP OSPF database router 1.1.1.1. Okay. So here, see, there is information about this router. So router, this is router 1. R1. My host name is, let's say, R1. After that, see the number of link. How many links are there? Number of links are 3. Okay. So first it will check the network connected to, as I told you, the stub network means link connected to stub network means directly connected network. Means one network is directly connected with me. And network ID of that network is 12.1.1.0 and subnet mask is 255.255.255.0. Means one network is connected with router number 1, where network ID is this one, subnet mask is this one, and metric on that link is 1. Okay. After that, there is one more directly connected link where network ID is 10.1.1.0 and subnet mask is this one. Okay. Then it will check LSA1 of router 2. 2.2.2.2. This is LSA1 of router 2, and here you can see total number of link is 5. Link connected to another router point to point, and router ID is 1.1.1 of that router. Means router 2 is connected with one router whose router ID is 1.1.1. Definitely it's talking about me, means about router 1. As you know, router ID of router 1 is 1.1.1. Okay. And IP address of the interface is 12.1.1.2. Okay, I am connected with one router. By checking LSA1 of router 2, it will came to know that I am connected with one router and their IP address is, this is R2. And IP address on that link is 12.2. Here IP address is 12.2. Done. Yes or no? And metric on this link is 1. Metric of this link is 1. After that, link connected to subnetwork. Definitely it is talking about segment which is running between router 1 and router 2, because here you can see IP address is 12.2 and network ID is 12.1.1.0. It is talking about link between router 1 and router 2. So metric on this link is, here also we can see 1. After that, link connected to another router point to point. Okay, router 2 is connected with one more router whose router ID is 3.3.3. And what is router ID of this router 2.2.2.2. Actually, it is checking LSA of router 2, whose router ID is 2.2.2. Okay, so router ID of router 2 is 2.2.2.2. This is how router can check the entire topology information. See, in the database, everything is available. Okay, after that, one more router is connected point to point. So, okay, and router ID of that router is router ID of that router is 3.3.3.3. It is talking about R3, right? Okay, and here you can see the matrix and the IP address of router interface. IP address of this interface is 23.2. Matrix on this link is 1. All informations are there. Done. After that, stub network means it is talking about the network which is running between router 2 and router 3, because here you can see IP address is 23.2 and this is the subnet. Means it is talking about the link between router 1 and 2, network which is running between router 1 and router 2. Matrix of this link is 1. We already know this. After that, link connected to a stub network. Link connected to a stub network 20.1.1.0. Like router 1, in the LSA1 of router 1, we are able to see one. This is link connected to another router, means 2.2.2 neighbor. And after that, link connected to a stub network. It is talking about the link between routers. And after that, one more stub network is there, that is 10.1.1.0. So we have one LAN here. And in this segment, we are using IP from network 10.1.1.0/24 by checking their own database on LSA1, right? And here you can see the matrix of this link also. Done. Then it is going to check the LSA1 of router 2. Okay, it have checked LSA1 of router 2 also. Now it is going to check LSA1 of router 3. Okay, and here we have found that one stub network is there connected with router 2, one stub network, and there I am running which network? You can see here. I think this is LSA1 of router 2, yes. Link connected to a stub network where network is in 20.1.1.0, 20.1.1.0/24, right? After that, it is going to open LSA1 of router 3. So IPOSP of database 3.3.3.3. So in LSA1 of router 3, how many links are there? 3. Link connected to another router point to point, and neighbor router ID is 2.2.2.2. Definitely is talking about router 2. Okay, and IP address is 23.1.1.3. My IP address is 23.3 over here. So we have found the IP address of router 3 as well. After that, link connected to a stub network means directly connected network, and here subnet is 23.1.1.0. It is talking about the link between router 1 and router 2. Okay, matrix on this link is 1. Then link connected to a stub network. Here again we have one more stub network, and where I am running network 30.1.1.0. So one switch is connected over here as well. And here I am running network 30.1.1.0/24. This is my topology, yes or no? So by checking database of router 1, I can design entire topology. If you will check the database of router 1 very carefully, you will find all information which is required to design the complete OSPF topology. Getting my point, guys? So with the help of router LSA, one router can view entire topology within area. Is it clear to everyone? Link connected to another router means neighbor router. and link connected to stub router means directly connected network. Okay guys, can I move?
Yes, sir.
Okay. Here if I will, change the network type to default network, that is broadcast. Here I am going to change network type. Interface F0/0 IP/OSPF network. Again I am going to set broadcast. On router number 2 also enable config interface range F0/0 and F1/0 IP/OSPF network broadcast. Done. And on router number 3 also I am going to say enable config interface F0/0 IP/OSPF network broadcast. Here I have set network type broadcast on all routers. Wait for some time to form OSPF neighborship again. Okay, OSPF neighborship is up, I think. To access start to down, no. On router number 1, so IP OSPF database. In database, here in router 1, LSA1, how many links are there? 2. Means on serial link, router consider their neighbor as a link. On serial link, whenever network type is point to point, that time router consider their router as a link. So here you can see once I have configure network type broadcast, number of link in LSA1 of router 2 is 2. This is actual, means it is not considering their neighbor as a link. So IP OSPF database router and 1.1.1.1. Now if I will open database of LSA1 of router 1 in detail, you can see total number of link is 2. One is 12.1.1.2 and one is 10.1.1.0. Okay, but in database now we have LSA2 as well, network LSA as well in the database. This is LSA1, these are LSA1, 3 number of LSA1 and 2 number of LSA2 are there. So who is generating LSA2? One router is 2.2.2 and one is 3.3.3. Router 2 and router 3 is generating network LSA2. So now let's discuss LSA2. So first of all guys, let me know LSA1 is clear to everyone. If anyone have any question in LSA1, then please ask me. It is very simple that each routers in OSPF domain generate LSA1 and LSA1 cannot cross the area. It cannot cross the area, so it will flood within area. And in this LSA, in router LSA, router ID will be the router ID of advertising router and link ID will be also router ID of advertising router. Guys, in some LSA, link ID will be maybe prefix information, means network information, and in some LSA it will be router ID. In some LSA it can be IP address also. Link ID can be router ID, it can be prefix or it can be IP address. In LSA1 it is router ID. Now let's discuss about LSA2. Okay, so here I am going to design one simple topology. Router 1, 2, 3 and 4. I am going to connect one switch here, or let me design this topology in GNS3 na directly. Okay, here I am designing switch router 1, router 2, router 3 and let's say router 4. So this time you can see all routers are connected in single segment. Here let's say we are running network. This is R1. Okay, router ID on router 1 is, let's say, 1.1.1. Router ID, or I can create this loop back on router number 1. So automatically that IP address will become router ID. Here we will configure 2.2.2.2 as a router ID. Here I will configure 3.4.4.4 as a router ID. And here I will configure 3.3.3 as a router ID. Okay guys, and let's say here I will use IP address from this network 192.168.10.0/24. Okay, this is my common network. On router number 1, let's say I will configure IP address 192.168.10.1 on router 1. On router 2, I will configure 10. Let's say 2 is the IP address of router 2. On router number 4, I will configure 10.4, and here we will configure 10.3. Okay, this will be my IP configuration. Guys, now here we have some concept of DR and BDR first. Let me discuss that. Then I will start LSA 2, that is network LSA. Okay, here when I will configure OSPF on all routers, okay, all routers have one network. Let's say this is LAN, which is connected on router number 1. This is also LAN, this is also LAN, this is also LAN. So router need to exchange these network information. So as you know, OSPF maintain database, and it's here LSA. Okay, so router 1, if I will talk about the database of router 1, tell me how many LSA 1 will be there inside the router 1 database. LSA 1, how many LSA 1 will be there? 4 number of LSA 1 will be there. Yes or no? LSA 1 of 1.1.1, LSA 1 of 2.2.2, 3.3.3 and 4.4.4. Yes or no? Here also in the database of router 2, there will be 4 number of LSA 1. Here also there will be 4 number of LSA 1, and here also there will be 4 number of LSA 1. Yes. And how many total number of adjacency router 1 will have? Full adjacency. Full adjacency with router number 1 also, router number 2 also, and router number 3 also. Yes or no? How many neighbor are there of router 1? 3. So when router 1 will share their database to router 1, so it will receive from router number 3. Router 3 will share to router 2 also, to router 4 also. And when router 1 will receive it, again router 1 will share the same LSA to their neighbor R2, R4. Yes or no? So see the flooding, guys. Actually same information in the same way. When router 1 will advertise their LSA to router 3 and router 2, router 2 and router 3 will also advertise to their neighbor, to router 4 and router 2, and router 2 will advertise to router 3 and router 4. Yes or no? So all routers are flooding lots of LSA. Yes or no? Here in this segment. In this segment, number of flooding is very high because of number of adjacency, because of large number of adjacency. If I will talk about the total number of adjacency in this domain, so can anyone tell me how many total number of adjacency are there?
12, sir.
12, because each routers have 3 number of adjacencies, so 12 number of adjacencies are there. And see, whenever I will add one network over here, right, so this router will again flood LSA1, because now in the LSA1 there is some change, so it will update LSA1 with higher sequence number, and it will advertise to router 2 1 and router 4. Again it will advertise to their neighbor. So whenever change will occur in LSA1 of any router, all router will execute their SPF algorithm. So whenever change will occur, again flooding will be there, right? And because of this flooding, maybe bandwidth on the link is not available for user communication. So when user is trying to communicate, they are getting, error. So this can be problem here. Problem is, guys, you know why? Because we have 4 routers connected with single segment, means all routers are directly connected with each other. Like this is a classroom, and in this classroom there are 40 students, right? Someone is coming in this classroom and they are asking what is the date today. Let's say what is the date today, and if everyone will speak, means 40 students will speak the day of today, right? Maybe this person will get confused. That is what flooding. So to reduce this flooding, what we did, we selected one person as a monitor. Then whenever someone will come in class, you will be responsible to answer them, yes or no. Why we have monitor in class? To reduce the flooding. Like this, if you want to reduce this flooding, you have to come with DR and BDR concept. Out of these 4 router, one router will be your monitor router. One router will be monitor router, that will be DR. That monitor router is DR, designated router. And all other router will be DR other. DR other and DR other. And DR other and DR other cannot form full adjacency neighborship. Neighborship between DR other and DR other will be till 2A. Okay, here also neighborship will be till 2A. Here neighborship will be full. Here neighborship will be full. And here neighborship will be full. Now how many adjacency are there, guys? How many total number of adjacency are there now?
3, sir.
Only 3. So with the help of DR BDR concept, we can reduce the flooding.
LSA flooding.
LSA1 flooding, we can say, right? And we can reduce the number of adjacency as well. So this is the reason why we come up with DR and BDR. Now in this topology, there is full neighborship between router 1 and router 3. There is full neighborship between router 3 and router 4 and router 3 and router 2. So how router 1 will exchange their database? Router 1 will share their database to router 3, and now it is responsibility of router 3 to advertise it to router 2 and router 4. So only router 3 will advertise it to router 2 and router 4. Okay. In the same way, router 2 will advertise their database to router 3, means it will share to the R3, and R3 will share to R1 and R4. Whenever any change will occur, DR other router will share information, change information to DR router, and DR router will share to other neighbor. This is the concept. Okay. So router 2 will learn LSA1 of 1.1.1.1 via router number 3. Here. Okay. Now question is, okay, this router is DR router. Let's say router 2 have advertised their LSA1 to router 3, and router 4 have also advertised their LSA1 to router 3. Now it is responsibility of router 3 to advertise it to router 1. So it will advertise 2 and 4, LSA1 of 2.2.2, LSA1 of 4.4.4 to router 1, right? So router 1 will get 2.2.2.2, LSA1 of 2.2.2 and 4.4.4.4 and 3.3.3.3. It will get LSA1 of all router. But how router 1 will came to know that how many routers are there in this segment? That is unknown for router number 1. So that's why actually router 2 will share LSA2 to all their neighbor. one LSA2 to this neighbor, and one LSA2 to this neighbor. In LSA2, router will share total number of attached router in this segment. So this is use of LSA2. DR router always generate LSA2 to share attached router information. Okay, let me configure this topology first. Okay, so again I am
Sir,
going to take yes.
sir, how many adjacency will be there total? Actually, it
After
should
DR
be
and
6.
BDR,
No, total adjacency after
see
DR BDR.
formula is n
N into n minus 1 by 2, no?
n minus 1. What value here you will get? N is number of router.
Routers.
So how many routers are there?
4. 4 cross 3 is 12. Initially, it will be 12 when there are no DR BDR, correct? But
Yes.
uh, after DR BDR, it should be divided by 2, no, sir? N into n minus 1 by 2.
After divided by there will be 3 number of adjacency only. 3 number of adjacency. There are no BDR, brother.
Okay.
If there are BDR, then that formula is applicable. See,
Okay, here only.
we have BDR
only.
as well. Like if DR will goes down, then which router will take responsibility of DR? So that's why one router will become BDR in this topology as well.
Okay.
Can anyone tell me which router will become DR router? Election of DR is what?
Router
DR will
4.
be based
10.4.
10.4.
Oh,
Yes.
sir, R4.
4.4.4 is
4.4.4.
Yes, Nirav?
Sir, which is the DR actually?
Yes. Which router will become DR?
DR will become 4.4.4 and on the basis of router ID.
What is the election criteria of DR?
Election criteria of DR is firstly
First.
priority number, and if there is a tie, then comes router ID.
Okay, first one is highest priority. Okay.
Priority. And default
What
priority
is
is
default
1.
priority?
1.
Priority, and its range can be from 0 to
0 to
255. And by default it is 1 on Ethernet link.
Yes.
Okay, after that,
After that, it will come router ID.
highest
Router ID.
router ID. Then so each router will
Loopback,
have
sir.
one router
Loopback.
ID.
Loopback after.
Highest IP physical interface.
No, see, router ID of one router will be unique in OSPF domain. So, okay, according to this, by default priority is 1, router 4 will become DR. But this will happen if I will configure OSPF on all router within 40 seconds. Let's say if I have configured router 1, OSPF on router number 1, after that I will wait for 40 seconds and then I will configure OSPF on router number 2, router number 4. Then do you think that router 4 will become DR?
No, because there is no preemption by default.
Yes, there is no preemption by default. Means once one router will elected as DR, even we have more router with higher router ID or higher priority, that router will not become DR. Okay, whenever we are configuring the OSPF on interface, that interface will wait for 40 seconds only, for 40 seconds. See, on router number 1, first of all, let me configure the IP. Interface loopback 1 and IP address 1.1.1.1 255.255.255.0 exit interface f0/0 no shut, and IP address is 192.168.10.1 exit router OSPF 1. And okay, I don't need to define router ID, automatically it will elect 1.1.1. After that, interface F0/0 IPO SPF 1 area 0. So I have enabled OSPF over here. So IP OSPF interface F0/0. So this interface here you can see state is waiting. Means for DR and BDR it is waiting. By default priority is 1. After 40 seconds, if it will not receive any hello message with higher router ID
It will.
or higher priority, it will declare yourself as DR.
DR.
It will wait for 40 seconds only.
Yes.
Okay, and here also you can see the wait time. Wait time is 40 seconds. So let me check now. Still it is waiting, and now you can see this interface is declared that I am DR. Okay,
Yes.
let me enable OSPF on loopback interface as well. Interface loopback 1 and IP OSPF 1 area 0. Done. I have configured the OSPF on router number 1. Let me take you to router 2 and config T interface loopback 1 IP address 2.2.2.2 255.255.255.0 let's say, and interface F0/0 IP address 192.168.10.2 255.255.255.0. Done. A router OSPF 1 exit interface F0/0 IP OSPF 1 area 0 exit interface loopback 1 IP OSPF 1 area 0. Done. Router 2 configuration is also done. And guys, on any router, if you like, what I want, my requirement is, let's say router 2 should never become DR, right? Means router 2 should be always DR other. Let's say hardware configuration of this router is not good, so I don't want to configure this router as DR or BDR router. So what I can do,
Set priority as 0.
we can set priority as 0. How I will set priority?
IP
Interface
OSPF priority under the interface.
IP OSPF priority, and I can set it 0.
Priority.
Now
0.
this router will be always DR other. So IP OSPF interface F0/0. Here also you can see it. So IP interface brief. This interface is done. Interface F0/0 say no set. So IP OSPF interface, see state is DR other. Okay, it will not take time to declare this interface as DR other. Once you will set priority 0, so state of that router will become DR other. Now let me configure R3. Interface loopback 1 IP address is 3.3.3.3 255.255.255.0. No set. Interface F0/0 IP address 192.168.10.3 255.255.0. Done. Sorry, interface F0/0 no shutdown. Exit. Router OSPF process 1 router ID will be 3.3.3 and interface range F0/0 and loopback 1. Can I use command like this? Yes, I can use. So IP OSPF 1 and area 0. OSPF configuration on router number 3 is also done. Let me configure priority 0 as well. IP OSPF priority 0, so that this router will not become DR and BDR. Now let me configure R4. interface loopback 1, IP address 4.4.4.4, 255.255.255.0, IP OSPF 1 area 0 exit interface F0/0, no set, and IP address 192.168.10.4, 255.255.255.0. Done. Sorry, interface F0/0, IP OSPF 1 area 0 and IP OSPF priority 0. Done. So IP OSPF neighbor. So see, this is neighbor table of router 4. Router 4 have 3 number of neighbor, but router 4 have only full adjacency with one neighbor, that is 1.1.1, because 1.1.1 is DR router. Yes or no? After that, here you can see neighborship state between router 4 and router 2 till two-way. Neighborship state between router 3 and router 4 two-way. Here we have two-way, here we have two-way, here we have full adjacency. Done. Now see the database of any router, like database of router 4. So let me open so IP OSPF database. See, these are router LSA. This is router LSA of router 1, router LSA of router 2, router LSA of router 3, router 4. Here you can see advertiser, router ID is router ID of that router. And here we have information about number of link and sequence number. Okay. And then we have one network LSA. Who is advertising this network LSA 1.1.1? Because actually this is not 1.1.1, because 1.1.1 is DR router. So DR router generate this LSA. And if you will open this LSA in detail, so IP OSPF database and network 1.1.1.1. So see here, sorry, here we can say 192 link ID 192.168.10.1, this one. So see, in this LSA, we have just information about attached router. How many routers are there? This is the purpose of LSA 2. So only DR router generate LSA 2 to share attached router in a single segment. Done. Done, guys. Here you know DR and BDR election will happen on the basis of segment. Like on this segment we will have one DR and BDR, and on this segment we will have one DR and BDR. So router is not becoming DR or BDR, router interface. Out of these two interface, one interface will become DR. Out of these two interface, one interface will become DR. Okay.
Election is done on power interfaces, not router.
Yes. Not router. Not router.
Sir, this is a point-to-point network, no, sir?
Yes. Here we have configured broadcast network type.
Broadcast.
By default, network type on Ethernet link is broadcast.
But in this kind of a network, I think there is no BDR, DR and BDR.
In this type of network, DR and BDR is not required. Definitely here you can see we will have only one number of adjacency. So DR and BDR is not required here. That's why I told you that network type should be broadcast, should be point to point here. Network type should be point to point, and on point to point network type, router DR and BDR election is not happening. Okay. So whenever you are, whatever link you are using between router and you are configuring, let's say OSPF, so you will definitely change network type between router, because network type should be point to point to avoid DR and BDR election, because DR and BDR is not required here. DR and BDR is good to reduce the number of adjacency. Here we have only one number of adjacency. We cannot reduce it with the help of DR and BDR. And brother, you know what is the use of sequence number? Let me make you understand that also. let's say this is a topology, right? Router 1 is my DR router, right? So router 1 have LSA 1 of 1.1.1.1, 2.2.2.2, 3.3.3.3 and 4.4.4.4. LSA 1 of all routers, and router 1 will share these LSA 1 to router 2 and to router 4, right? With sequence number, let's say 5. Sequence number is 5. So actually when router will receive any update message of OSPF, it will check the sequence number coming in the update, and after that it will match the sequence number in their database. If both sequence number are same, then router is not going to decapsulate this update packet. It is going to drop it. If it will receive any update message with higher sequence number, then only OSPF router is going to process the update message, because size of database is very large. Okay, so that's why we have concept of sequence number. Let's say router 4 will advertise same network information to router 2, right? So it will advertise with same sequence number 5 and 5, but router 2 have already received this network information with sequence number 5. So it is again receiving with same sequence number, so it will not process this update message. It will discard it. And when router exchange sequence number, you already know in X start state with the help of DBD message. Yes, Rohit, clear to you?
Yes, sir. Yes.
This is concept of sequence number. Now LSA 2 is clear to everyone? Any dot in LSA 2? Okay. Now guys, let's say
Sir, LSA2 will also not cross the area, correct?
LSA 2, yes, LSA 2 cannot cross the area.
Okay.
LSA 1 and LSA 2, both LSA cannot cross the area. Let's say I have router 1 here and router 2, router 3 and router 4. Here I have one LAN and one LAN we have here. R4, this is switch, this is switch. Here I am running network 192.168.10.0/24, and here I am running, let's say, network 192.168.20.0/24. Then between routers I am using network like between router 1 and router 2 12 network, between router 2 and router 3 23 network. Done. Now just consider that this is OSPF different area and this is OSPF different area. Let's say this is OSPF area 0, PF area 0, and this is OSPF area 1, area 1. Okay, so first of all, let's say router ID of router 1 is again 1.1.1, router ID of router 2 is 2.2, router 4 4.4.4. Okay, so router 1 will have how many number of LSA 1? First of all, tell me that how many LSA 1 will be there in the database of router 1?
Oh.
LSA 1 of 1.1.1, LSA 1 of 2.2.2.2, and LSA 1 of 3.3.3.3. So there will be 3 number of LSA 1 in the database of router 1 also, in the database of router 2 also, in the database of
Router 3 also.
Router 3. Router 3 will have how many number of LSA1? 1.1.1 also, 2.2.2 also, 3.3.3 also, and
Oh yes.
4.4.4.4 also. Yes or
Yes,
no?
yes, sir. Yes, yes. It is ABR. Sorry.
And router 4 will have 4.4.4.4 LSA1 and 3.3.3.3 LSA1 of 3.3.3.3. Yes or no? As I told you, LSA1 cannot cross area. LSA1, router 1 will generate their LSA1 and it will forward to router 2. Router 2 will forward to router 3. And see, router 3 will not forward it to router 4 because this interface is in different area and this interface is in different area. So LSA1 cannot cross area. That means router 4 will never get to know about this network 192.168.10.0. Definitely yes. Router 4 will never get this network information and router 1 will never get this network information 192.168.20.0. Yes or no?
Yes, sir.
So actually here I need to share prefixes of this domain in this domain and prefixes of this domain in this domain. Yes, this is my requirement. So automatically ABR router will generate LSA 3. In the form of LSA3, ABR router will share all prefixes of OSPF area 1 into area 0 and all prefixes of area 0 into area 1. Now question is, what is ABR? So guys, ABR is a type of router in OSPF and type of router who have one interface in area 0, at least one interface in area 0 and at least one interface in any other area. Like router 3, you can see one interface is in area 0 and one interface is in any other area. Maybe area 1, area 2, area 3. So that type of router will become what? ABR. So here perfectly my router 3 is ABR router. So router 3 will generate what? LSA3. How many LSA3 it will generate? 2 number of LSA3. One for this area and one for this area. So now if you will check database of router 1, there will be LSA 1 as well and there will be one LSA 3 as well. One LSA 3 for one prefix. Okay. So LSA 3 is summary LSA. Which type of router will generate this LSA? So ABR router will generate. What is ABR router? Types of router whose at least one interface belongs to area 0 and at least one interface belongs to any other area. That type of router is ABR router and ABR router generate LSA3 to share inter-area prefixes. Now guys, let me ask you very easy question. Here I have again, let's say 3 router 1, router 2 and router 3. Here I have one loopback 1.1.1.1. Here I have one loopback 2.2.2.2. Let's say this is OSPF area 1, OSPF area 1 and this is, let's say, OSPF area 2. R1, R2 and R3. Now this time tell me, R2 will generate LSA3 or not?
Sir, no.
No, sir.
This time it will not generate LSA3 because this router is not your ABR router. Right, this time R2 is not ABR router. So always keep in mind, two regular area cannot communicate with each other. If I will talk about the basic area concept of OSPF, so guys, there are two types of area. One is backbone area and another one is regular area. backbone area is
area 0.
area 0. Area 0 is your backbone area, and all area except area 0 is regular area. All areas except area 0. Okay. So AVR router is router whose at least one interface belongs to backbone area, means area 0, and at least one interface should be in any other area. That type of router will automatically become
ABR.
ABR. Done.
So, sir, in this particular scenario, which you are showing area 1 and area 2, the router, in this scenario, basically, there can be two types of configuration for sharing the prefixes. One is redistribution, correct?
Yes.
Another is that is an advanced topic in OSPF only. That is, I guess, virtual link tunneling.
Okay. We have one more option. I can create one loopback here and I can put that loopback in area 0.
Oh, on
No.
R2, on R2.
Yes, definitely on R2. If one interface will enter in area 0, definitely this
Okay.
router will become AVR.
Yeah, yes. That is
Don't
also-
you think that?
Yes, sir, yes. Other than that, route redistribution and virtual link tunneling.
Virtual
will
link.
do. Yes.
For virtual link, where is area 0? We don't have area 0 here.
Yeah.
So
So,
we cannot configure virtual link here.
no, if it is available, then we need to create.
Yes, then we need to.
But this, sir. So, as you said, if we create loopback and put it in area 0, so this will work, no?
Yes, this will also work, na?
Okay.
Router whose at least one interface belongs to area 0 and at least
Yeah,
one
yeah,
interface belongs to any regular area. That type of router is ABR router. That's
Yeah,
it.
okay.
Okay. Now, guys, you know, in LSA 1, there is one flag field. In LSA 1, we have one flag field. In flag field, we have three types of flag. One is B bit. Second one is E bit. And third one is V bit. We have three flag inside LSA 1. I can show you in the capturing. We have one flag. In that flag, you will see these three field: B field, E field, and V field. Whenever a router become ABR, that router will on this bit in their LSA 1. Whenever router, if router 2 is my ABR router, then whenever router 2 will share their LSA 1, it will on this bit, B bit. So R1 can easily know that R2 is my ABR router because it will on B bit in their LSA 1. Which router? ABR router, right? Whenever a router, first understand what is ASBR. So like ABR is a router whose at least one interface belongs to area 0 and at least one interface belongs to any other area. Like this types of router whose at least one interface belongs to OSPF domain, doesn't matter in which area, at least one interface in OSPF domain and at least one interface in any other routing domain. That type of router is known as ASBR router. That means Autonomous System Border Router. ABR stands for Area Border Router. It is separating the area. It is connecting the area, ABR. And ASBR is connecting to different routing domain. Autonomous System Border Router, ASBR. Router whose at least one interface belongs to OSPF domain and at least one interface belongs to any other routing domain. That type of router become ASBR. And whenever a router become ASBR, they will on E bit in their LSA 1. Which router? ASBR router on E bit in their LSA 1. By default, normal router forward LSA 1 with these bit off. These bit off. ABR router will on B bit. ASBR router will on E bit. And when we will configure the virtual link, then we will understand V bit as well. This is for virtual link. endpoint of virtual link. We can configure endpoint of virtual link with this way. So we will understand it while discussing virtual link. Okay. So this is how router 1 will came to know about ABR router. And let's say this is not my topology, this is my topology. Here we have area 0, area 1, and let's say router 4 is connected with one more router here, and between this router and router 4 I am running any other routing protocol. Let's say here I am running EIGRP in this domain. Done. So router 4, see, router 4 have some interface in OSPF domain and one interface in, let's say here I am running EIGRP, so in EIGRP domain. So router 4 will become what? Router 4 will become ESBR. ASBR. And router 3 is your ABR. ABR. Now question is how router 3 will came to know that router 4 is ASBR. So it will send
EBIT once.
EBIT on LSA 1. Now question is how R1 will came to know that which router is ABR. So R3 will on which bit? B bit in their LSA 1. Like router 1 have information that which router is ABR router. Now question is how router 1 will came to know which router is ASBR, because OSPF router need complete topology view. So router 1 need to know which router is ASBR router. So router 3 already know about ASBR.
Router
Right?
3 will
To
send.
share ASBR network information in different area, again ABR router is going to generate one LSA, that is LSA 4. LSA 4. What is the purpose of LSA 4? To share ASBR information. That ASBR is 4.4.4.4. Right? Now whenever router 1 will receive any external prefixes, what will be the, doesn't matter what metric will be there. It will be at the metric to reach ASBR 4.4.4. So total metric will be metric which is coming in update plus metric to reach ASBR, because router 1 will receive prefixes from router 4 with default metric which is coming from router number 1. Let's say we are advertising EIGRP prefixes in OSPF domain. So metric of EIGRP prefixes over here will be same. And each router will add distance to reach ASBR. So all routers should have information about ASBR. What is the cost to reach ASBR router? Okay. So ABR router generate two types of LSA. It is very clear. LSA 3 and LSA 4. LSA 3 is to share inter-area prefixes and LSA 4 is to share ASBR router information. Okay. So now what I'm going to do, I'm going to implement it over here in this topology. Let me check I have any topology or not for the different area. OSPF. Okay, let's see, this is my topology. In this topology, guys, tell me which router is ASBR router. How many ASBR are there? ASBR, Autonomous System Border Router.
Two. Oh,
Two
sorry,
router
ASBR, no, sir?
ASBR.
Yeah,
ASBR.
two, only two.
Router 2 and
8.
R8.
router 8. And how many ABR are there?
R4, R5, R3,
4.
R9.
R9 is also R9 is not ABR, brother.
Okay.
Only 4.
Both
4
interface
ABR.
belongs to regular area.
Only 4. R2, R4, R5, R3.
Yes. Okay. So let's say we have some prefixes on router number 7. If I will create some loopback on router number 7, so router 7 will advertise it to router 4, router 5. And these two routers are ABR
ABR.
router. These two router. So these two router will generate what? LSA
3.
3. In the form of LSA 3, it will share this network information to router number 1. First of all, let me check. I think I have already configured OSPF here in this domain. Let me check the configuration. So IP route OSPF. So yes, it is receiving some prefixes, some external prefixes as well from OSPF. That means topology is already configured. Now let me check database. So IP OSPF database. In database, guys, let me maximize it. Okay, this is LSA1. This is LSA1. All routers in this domain is generating LSA1. 1.1.1, 2.2.2, 3.3, 4.4, 5.5.5. See, all routers are belongs to this domain. Yes or no? So all routers have generated their LSA1. Okay. After that, we don't have any LSA2. Directly we have LSA3. So who is generating LSA3? Two router, 3.3 and 4.4. 3.3, 4.4 and 5.5. That means these are ABR router 3.3, 4.4 and 5.5. Router 3, router 4 and router 5. See, all ABR router are generating what? LSA 3. Because advertising router ID is 3.3 and 4.4, 5.5. Okay, after that LSA 4. Who is generating LSA 4? 4.4.4 and 5.5.5. 4 means router 4 and router 5 only. Router 4 and router 5, because here is ASBR, router 8 is ASBR. So it is sharing information of which router. See here, it is sharing information about router number 8. So router number 8 is your what? ASBR. So router 4 and router 5 is advertising LSA 4 to share ASBR network information. Why router 3 is not generating LSA 4? Because router 3 don't have any ASBR. Yes or no?
Yes.
Okay. After that we have external LSA 5. Who is generating? 2.2.2 on and 8.8.8 means only ASBR router. So ASBR router generate what? LSA 5 to share external prefixes in OSPF domain. Actually router 8 is generating what? LSA 5 to share these prefixes. And one more router is generating router 2 to share these prefixes. And that's why router 1 have learned these prefixes. If you will check database again of router 1, you can see 100 prefixes. So it is receiving these all 100 prefixes from router number 8. Advertiser router ID is 8.8.8. And here link ID is, in link ID information is prefix. Prefix information are there inside the link ID field. Getting my point? Is it clear? All LSA 1 to LSA 5. Now see on router number 1, this is not router 1. So IP route 100.1.1.0. Okay, so this network is there in the table. Yeah, a metric is distance metric So IP OSPF database. See, in their database there is one LSA5. In the LSA5 there is one prefix 100.1.1.0, right, via 8.8.8.8 via router number 8. So it will open this LSA in detail. If I will open this LSA in detail by running command external and then 100.1.1.0. So see, the metric is what?
20.
20. And so IP route OSPF. In routing table for 100 prefixes, metric is what?
20. So that is the advertised distance, basically from
Yes,
R8.
exactly. So your total metric to reach in this network is not 20, brother. It is 20 is the metric from router 8 to destination. And
Yes,
router
sir.
1 is also also getting prefixes with same metric. This is SID metric in OSPF.
Yes. We need to configure so that it comes as a 0 E1.
Yes, E1. Okay, so that configuration maybe we will discuss tomorrow. And we have only one more LSA, that is LSA 7. So while filtering we will discuss LSA 7. So till now please practice these LSA 1 to LSA 5. Please configure the topology, right? Design a topology where you have multiple area and then try to identify which all types of LSAs. Okay, if I will run one command on router number 8, where is router 8? I need to take access of router. On router number 8, what I will do, I am redistributing these prefixes in OSPF. So I am going to change metric type. On router number 8, go to router OSPF process 1, I think. OSPF process I need to check. So I can run command show IP protocol. Which process is running? Yes, 1. So config t router OSPF process 1 and redistribute ESERP, and I need to check the ES number. So ES number is 200 and subnets. So we will understand the meaning of subnets while understanding redistribution. Just I am running one command here, metric and then type, I think, yes, type. And now we can set it to type 1 and type 2. By default it is
Type 2.
2. So if I will configure type 1, so now router will calculate total metric. Okay, so now on router number 1, again I am going to check their routing table. So IP route OSPF. Now metric is 23. So how this router have calculated metric 23? Because see, metric which is coming in update is what? 20. And total cost to reach 8.8.8 is what?
3.
3. Yes. So total metric from router 1 to destination will become what? 23. Yes or no? You can run command show IP OSPF border router to check ASBR and ABR network information. Like you can see 4.4.4 is ABR router reachable via this IP address. Okay, who is ABR and who is ASBR. After that, so IP route OSPF also. Okay, you can run one more command here. So IP OSPF border router and detail. Not this one. Nope. Okay, leave. We have, I think, one command over here. So IP route OSPF. It is performing load balancing for these all prefixes. From router 4 and router 5, both are advertising with equal metric. Okay, so in this topology, we are going to discuss advanced topics as well. Okay, so topology will be same. You can also design this topology in your EVNG. And for now, please connect 3-4 router like this or in series, configure multiple area there and try to identify the LSA1 to LSA5, LSA1 to LSA5 only, where link ID is prefix information, where link ID is IP address. See, if I will run again, so IPOSPF database command on router number 1. So IP OSPF database. In database, we are able to see in some LSA link ID is router ID. In some LSA link ID is network ID. In some LSA link ID is again router ID. Again in some LSA link ID is network ID. Router advertising router ID is always same. Router ID of router who is advertising that prefix. Okay. Okay, guys. So this is all for today. Now we will continue from tomorrow. Before that, please configure multi-area topology.